Hey folks, I'm Vitor. I'm CTO of Pillar Project. I'm here to try to and talk to you guys about a new dev tooling initiative that's called Etherspot, and what Etherspot does, and why do we think that's important. Just in a brief recap, Pillar is one of the many smart contract-based wallets. There's a few out there. You guys are probably familiar with them. We've been in the market, I don't know, since 2018, and we've been integrating and designing interfaces for blockchain projects over this time, and we've been facing the UX challenges that everyone has to face, which, as you guys know, are painful. I'm gonna give you. I'll start with one example of a UX interface, and from there we're gonna go to like what the challenge is. One project I think most of everyone knows in the blockchain space is the Makoto's project, Kickback, right? Which is you can go and join an event and you put some money into that and just like stake, and people who don't turn out the event, they receive their stake to don't forfeit their stake. The people who did turn up to the event, they receive their stake plus a share of the stake of the people who forfeit their stake. Um, Plus has some donation mechanisms to pay for speakers, which is quite neat and nice. And I believe most everyone has faced this, and you'll probably have used it. And if you haven't, just check it out. It's a very nice project. So if you look at Kickback, and some of us who are a bit older or have been in the space for a while first use Kickback on what's called Ethereum mainnet, paying with ETH or DAI to join events. And this has become impractical in the last year or so due to the gas price, right? Every time you make a transaction for Ethereum, you're going to pay for the computing, you're going to pay for the storage, pay for accessing the storage, and this costs real money. And for applications who are not financial related, this often can become essentially extremely difficult. So one of the solutions that Kickback did, and you see it's a solution that's commonly considered by a lot of the apps, is to move into a sidechain or another layer, EVM layer one, that's essentially allows for cheaper transactions. In Kickback's case, that's XDAI, which is an excellent choice. XDAI is a very neat project, works very well, and you got like a burner wallet, you got many people using it. But let's go over the experience. If I just set up a computer, I bought myself some ETH, I installed MetaMask, I transferred my ETH over to MetaMask, and now I go to XDAI Kickback. When I get to XDAI Kickback, first thing it's going to tell me is I'm using the wrong network, because my MetaMask by default is going to be on Ethereum mainnet. So if we go from there, I need to either Google or follow the support links to understand how to add a new network to MetaMask. And this means I need to provide MetaMask an RPC endpoint. I need to provide MetaMask a chain ID, I believe. I need to name the network. I need to provide the block explorer link. I don't need to, but I can provide the block explorer link. Which are all technically, essentially, words are very easy to you know what it means as a dev, but you can't really expect an end user to go through this. It's a very high barrier to entry for adoption. For a lay end user that's not even a part of the blockchain church, the Ethereum church. So as a lay member of the public, you're asking them to say essentially the incantation, what's the RPC endpoint. So, but assume you did all that, and you instructed the user how to do that. So now the user has ETH or mainnet. Essentially, now you have to walk them the long way to go from ETH to DAI, from DAI to go to the XDAI bridge from the Pool Network guys and transfer the DAI to XDAI. So this is a long and convoluted way before they can use the app. And if you're as an app developer, the more gates you put in front of an app, that's your attrition rate, right? If you put a login barrier, that's you're gonna lose users there. If you put a word wall, you're gonna lose users there. And now look at the not using logins, not using ad walls. Look at how many barriers you put in front of an app. Essentially, in some of them actually require the user to go off browser, Google something, uh, fix something on an extension, come back. It's a very, very high ask if you're looking to do this for a lay public, a public that's not tech specialized. So our idea is to change a bit how this works and to bring down the barriers of adoption and build better interfaces powered by Etherspot and Pillar. So how do we get to that? Essentially, we have an SDK and a series of smart contracts and a series of services that we use to power those. We've got this services in place, and what do they do? First, let's break down a typical D app into its base components, right? So if you go to a typical D app, you've got a Web3 provider, be it, I don't know, a React app or a Vue app. Essentially, they tend to have a few components that are common among the apps. First, they have a way to sign transactions. Could be a Web3 injected provider. They could have a wallet connect instance. They have a way to sign transactions. Now they have a way to broadcast transactions. This might and often be the same in most of the structured applications. They're the kind of separate components that live beside together. So you're signing transactions, you're broadcasting transactions, you're reading and writing from the blockchain, you're making subscriptions from the blockchain, so you can subscribe to events. And this feeds into your local front-end state, and you go from there, right? The first thing we propose with Etherspot is breaking the signing component. It's having a very clear separation of purpose among the component that's supposed to sign a transaction and the component that's supposed to broadcast transaction. And this comes from a very, how they say this, a very strict interpretation of the meta transaction patterns. So now we have a signer and we have a broadcaster. They are not the same, and we make this very explicit. This is the first interesting component. The first with this, essentially means you're using, for example, an injected Web3 like MetaMask. We're gonna only use it for signatures. We'll never broadcast from it. This first provides us the first very nice benefit, which means MetaMask actually needs to know the RPC endpoints where we are going to. This is the first, let's say, level of indirection that we have that allow us to write an application that started in XDAI, that started Binance Smart Chain, that started whatever that's EVM compatible, without regarding the signer, be it a wallet connected wallet, or be it injected Web3 or whatever, you actually don't know where these transactions are going because it's actually not relevant. It's only relevant, they sign it using the similar on the account they possess, and from as long as the chain supports EVM and supports the same address space, this works. We always broadcast through using meta transactions. You can actually broadcast directly, but there's a separation of concerns. The signer and the broadcaster are different components. Now, with this first layer of indirection essentially means the user will never see a request to make a transaction. They will always see a request to sign a message. And this is a small UX barrier. This is a bit of a trade-off, right? Because wallets have a nice UI to deal with transactions. They don't tend to have as nice a UI to deal with messages. But this is what we hope to cooperate and change with wallets, starting with our own. which we can provide, of course, the best-in-class experience, and that's why it makes sense for us to go infrastructure as a wallet provider. Um, Help us with adoption on our side. But this essentially, but there's a very smaller barrier of adoption than the barrier of adoption for sidechain apps than actually ask users to add new networks or to be aware and cognizant of what a network is, what a chain ID is, what an RPC endpoint is, what the block explorer link is. So they will solve this first challenge. The second, to do this, one of the things that we do, we use counterfactually generated addresses for smart contract wallets. The seed for these addresses, they're all based into the salt. Sorry, for these wallets are essentially, is it salt? From the first address of this, the first smart account, the first externally owned account to use it. But essentially means using Cray2, this address is going to be one and same across all EVM chains that share the same address space, which is very, very nice. And this means that the user has one address per chain that works for them. They'll sign messages using whatever all the accounts they have, and they'll get all the benefits of smart contract wallets across chains. And now the user really doesn't have to know anything about how to set up their wallet, to connect to different chain. Actually, the user doesn't have to care where the chain lives, at least to connect. This brings us to the other bits of it. So now we're talking about smart contract wallets, and this may raise some flags, and they're generous. You're right to raise some flags and questions, and to ask, what about the overhead? If you deployed, for example, an Argent wallet, or if you deployed an OZSafe, you actually know this. While they provide you some degree of flexibility, like spending limits and tons of bells and whistles, they come with a cost, right? The user has to pay for deployment, which tends to be an expensive cost. And they come with an extra step, and you're trying to avoid them because they come with deployment step before the user can do their first transaction. First, our design choices are a bit different from NoSafe, from Argent. Pillar's Etherspot smart contract that created by Pillar has a quite a different design pattern from this. I'll compare it to Argent. So if you look at Argent, on OZSafe, they are modular and big, which is fine, which is a very valid pattern if you want the highest degree of flexibility. It comes, of course, with a cost. It means you need to point to the modules and either have a facade and multiple calls, but essentially means you're bringing a lot of stuff in. We instead of going for the kitchen sink approach, what I like to call the VW Beetle approach, sorry, the Volkswagen, the old Volkswagen, which they tend to be like mechanically simple and kind of runs forever, maybe like a Jeep. I'm not really a car guy, but I do admire the simplicity of this kind of machines. So we have a very big contract that essentially has all the possible rules and some monolithic contract that we call a account registry. And for all our wallets, we only have a contract that's called essentially it's a proxy contract that designates everything to the account registry, and it means our deployments are very, very, very small. We're not as modular, but our deployments are very cheap. And this comes with the second call. Essentially, one of the features of this account registry is the ability to execute a series of batched calls, so it can execute a series of transactions. And because we're using the meta transaction pattern, our first check in our relay backend is to check if you're using an account that's been deployed. If you're not using an account that's been deployed and you'll send the transaction, I'm going to actually execute two transactions. I'm going to execute the deployment one And batched, oh, execute the transaction actually in use. So we're gonna pay for deployment on the first use, and this is gonna bring a series of nice things. First is there are no deployment costs, and second, I don't need to have ETH in my account to actually pay for this deployment, or actually I can be smarter about it. For example, one of the nice ways to do this, I can actually, because I'm batching a series of transactions, I could be batching, for example, a transaction that take a flash loan, deploy a transaction, deploy a wallet, get some money out of received out of layer 2, pay back the flash loan. And now, essentially means I don't have anymore the need. I can receive account on my layer 2 and pay for it. So we are not completely eliminating the deployment aspect of the smart wallet. We are also give you freedom of possibilities on how you fund the user. And now I touched on the layer 2 point, and that's probably where we shine. And if you're familiar with the project, we've been playing around with state channels for a long time, and I thank our partners building this. We've talked to lots of space, good folks at Connect, James Young from Abridged. We've been working on this for a long time. And one thing that we did, that's already in prod, there's something we call the Pillar Payments Network, so state chain implementation. What we've done for Etherspot is generalize this. Now, because we have the same wallet address, the same contract wallet address on every chain, what we're doing is essentially when you pass a message on the smart wallet, now we're passing a chain ID. When you're passing a message on the layer 2, you're also passing a chain ID. And this chain ID essentially means I'm gonna route this to the right relay on, and now it also means that I've top up on. I can do what we call a bridge process. Like, let's say you have liquidity on mainnet, you have liquidity on XDAI, you can sign a message on. You can be pointing to mainnet, you can execute a message on XDAI. And of course, if you're familiar with the state channels, this means you have liquidity on both sides, or at least you have some way to ensure that you have enough liquidity to pay for your debt on whatever chain you're executing. What you're doing with Etherspot is breaking this, and that's quite a trick. On whoever is this, we're asking for people to submit liquidity on, for example, for an XI way, to deposit into Etherspot some amount of your XI, and now we allow users to top up into mainnet their channels, and now we're allowing for them to execute on any EVM that we have liquidity, and we're gonna settle it back for the user when we're gonna take out of his mainnet account, so we can pay for the liquidity provider, but to allow total flexibility of the user where they want to execute this. And now, if let's say we go back to our original flow with Kickback and XDAI, what we have to do, let's say we have a user, they have MetaMask, they have XDAI, they have ETH, and now what we're doing is generate a contract wallet for them on XDAI and mainnet, and that's all create too. So there's actually no transaction at this point. We would allow them to do one transaction, to ask them to sign one transaction topping up this account, and they will do that. No transaction has been submitted to the chain yet, and you ask them to sign another transaction to execute a payment on XDAI using the bridge. And now here's the build of it. Because we're batching these transactions, we're going to do this in essentially only two steps that will only be visible for the user once. So we're going to ask the user to tap, sign, and then I'm gonna go to the mainnet and I'll send a transaction to deploy his wallet, a transaction to top up his to make his deposit from his external account, and to put this on layer 2, which is natively supported by the smart contract. And now my relayer knows, and my guardian of the P2P system, payment system, knows that he can execute liquidity, and I can execute the third transactions, make a payment on XI. And the user doesn't need to know that kickback lives on XI or any other network. The user doesn't need to know the other network exists. The other thing the user is going to know, they're paying way less for every time they use, except for a bit overhead on the first transaction. So my barriers to entry have been all significantly lowered. That's why we built Etherspot. We're essentially removing all the steps that lead to that hang in front of the app. And we're quite proud of it.
Yeah, so this is our playground, and I will demonstrate the full flow, how the onboarding will look like on the Pillar wallet. So first, we will generate some random private key. We will probably store it somewhere in local device storage. And after creating SDK, we have wallet and key account with the same address. So wallet store the private key and is responsible for the signing messages. And key account, this is a account representation with the type of the key. So basically, this is a regular key account. On the next step, we can compute. We have two options. We can compute contract account from the key account. Because wallet and key account address is used as a salt for the contract account. Yeah, so I will do that.
In terms of smart contracts, what is wallet and what is contract account in terms of?
Okay, so deployer is a personal account registry, and there is only one single account contract. That's small contract with only execute transaction method, which is used as a bytecode for creating new contract using the curates too. So we have a deployer, which is a personal account registry. We have a salt, which is a address of wallet, and with that we can compute the contract address without deployment. So yeah, I compute it from the wallet, and I can also join account. But to join account, I need to have an address account. So first, let's say on the regular Pillar wallet, we will compute from the wallet account first. Yeah, and here is my contract account. It's stored in the personal account registry. It's currently undeployed because I just created, and the type is a contract. So from that moment, I can use it as a regular key account using the gateway. So let's say I want to execute the transaction. So in our local environment, we have a facet integration. So I can top up with, let's say, 5 ETH. And currently on my contract account address is 5 ETH. So I can go to the batch methods of the account, and let's say I want to execute a transaction to some kind of random number with value of 1 ETH. And here is the SDK call, and it will create the batch. So let's say I will add the first transaction to the batch, and let's say I can add another one. So from that moment, we have 2 transactions inside the batch. Then I can go to set that batch. First, I need to estimate it. So estimation is done on our backend side. And after clicking estimation, I get the total cost of the transaction. I can also use, I can refund with the VAY or with the token. Let's say I want to refund for the transaction, pay for the transaction from my contract account using the VAY. So I'm doing the estimation, and then I can submit it. And after submission, it's here. My transaction is in the queue on our backend. And in the background, I get the notification about the status of the transaction. So in the payload, I have a hash of that batch. So I can go to the gateway submitted batch, paste the hash, and now I see that my transaction is set. And also my batch is connected with transaction, because in our backend we have a window that we're collecting different batches from different accounts, and we are submitting them, let's say in one time per 10 seconds to reduce the gas costs. So multiple batch transaction can be connected with single transaction, but we also have access to that transaction, and I can check my contract account balance here, and it changed. So in that first transaction from that account, there was also deployment process. As you probably saw in the personal account registry, when the contract account is not deployed yet, we basically deploy it during the first transaction from that account. And also my...
I have a question here. So regarding the batching, so you batch the data that comes from like one transaction? Can you batch the transaction that's going from multiple transactions in the system too, or?
Yeah, I can batch. Let's say from the single account, I can batch multiple different kind of the transaction, different kind of interaction from that single account. But on the backend, we combine multiple batches. But let's say batch is a multiple transaction, and we have a batches which can be sent by once using our backend. And because of that, user, some of the, let's say, two different accounts can have a batch sent with in the same transaction.
So what smart contract would your backend submit this to? Just want to know.
Yeah, there's a gateway contract. All of the interaction with the blockchain, the right one, going through the gateway.
Okay.
So now you were like describing the basically gateway and payment personal account registry functions, right?
Yeah. The second thing is ENS. So ENS is it's built on microservice, so we can register some kind of, let's say, on local and testnet environment. We have top level domain pillar attached, so I can so it's empty. I can reserve it. So from that moment, no one can register that name, and it's assigned to my address, but it's stored only in our database. So if I go to get ENS node, I will get the state that is reserved. So it's not on the blockchain, but I can submit it using the batch. So I can climb ENS node without any parameter. I will climb my own one, and it will create the gateway batch. And just like before, I can go to the estimate and the submit, and I get the notification. So I get the notification that the batch is updated, ENS subnode is updated, and another update from batch. So after that, when I go to the ENS and I check my default ENS name, the state changed the claimant, and from that moment, it's already on the blockchain. Yeah, so this is a, let's say, account and ENS, and another section is the payments. So we have a contract payment registry. It's really simple mechanism. And we have another address, peer-to-peer payment deposit, which is compute from our account. So if we have a key account, the peer-to-peer payment deposit will be compute from key account, but in that situation, we have a contract account. So the salt of the peer-to-peer payment deposit will be our contract account. Currently is 0, and let's say I can top up it. I can send regular transaction to the account. I top up with 5 ETH. And I will create another instance of SDK. The fresh one. Just like before, I will go to the account section, compute from and this is a fresh account. It's currently not on the blockchain, and it has a balance 0. So I can now I can use my peer-to-peer payment to send some layer 2 payments to that account. I can increase, let's say, I can, because there is a channel between all of the addresses, and we cannot close the channel. It's always open, but we can commit the value inside the channel. So I will paste the recipient will be the address of that contract, and currently is 5, so I will send 1 ETH, and I create the payment. And the second account get the notification about the payment. The payment is created and updated. So that account can check the balance inside the channel. Yeah, it's 1 ETH right now. And let's say I will increase it with another 1 ETH. And another one. So I have 2 ETH here, and inside our payment channel,
so which part is off-chain and which is on-chain? So you can
everything now everything is what I presented now. Everything is off-chain.
So you're updating the balances, which are off-chain balances.
Yeah. Okay. So I get the notification that my channel is updated. So I can go to the get payment channel, and I have a 3 ETH right now. And that account doesn't have ETH, but it can use because transactions are in the batch. When I submitting them, it can use that amount which is in the payment channel between the first one and the second account to pay for the transaction. So we have a batch method here. I can commit that payment channel. And in that situation, I have 2 options. I can deposit, so I can withdraw everything from that payment channel. I can commit an amount withdraw to my peer-to-peer payment deposit or to my contract account using the withdraw. So I will withdraw. To do that, I need to set that flag to false. And I created a batch for that. So that account doesn't have any. So I can go to the gateway, I can estimate that batch and submit. And I'm getting the notification. And yeah, I get almost 3 ETH because I pay for the transaction. So I withdraw that amount from the channel to my contract account. And in the next batch, I pay for, I refund for the whole batch. And it was only 1 transaction.
So the balances, where are they stored? Is everybody's responsible for storing balances of their channels and their counterparties, or is it like centrally stored in your servers?
So we have a peer-to-peer payment deposit address. We can check the balance of, this is regular address. So we can check how many tokens, how many ETH is on that deposit. But also we have
not
another.
deployed yet, right? I mean, is it deployed initially with the balance, and then you do some transactions which are off chain, and you cannot check?
No. You don't need to deploy that contract. It's working similar to the contract account. It's also using the account controller and account contract for creating the account. It's really small contract. So this contract will be deployed on your first, just like contract account of the first transaction. It will be deployed first time when you want to withdraw something from that deposit. So, for example, your recipient will submit the channel, because you can update the channel, but you don't need to commit. You can commit whenever you want.
So who's storing the current channel state? Is it like two of the counterparties, or how is it happening?
The state is stored. The state is stored in the signature, so we are storing in database. So when I sending something to you using the peer-to-peer payment, I'm sending you signature. So this is a proof that I'm sending you something, and you need to have another proof for our guardian from backend. So that two signatures is required to commit the channel.
So basically, there is your backend that stores all the signatures and all the states of all the channels also.
Yeah, and also SDK instance store that.
So like the question is like,
yeah, it's here.
Who's preventing me from double spending money from one?
Yeah, for double spending money, there's a guardian for that. Guardian on our backend have a list of all of the payments and secure that there is no double spending.
Mm-hmm. So every transaction is coming through your guardian. I cannot see that from the code, right? So it's only like from the smart contract.
Yeah, but because it's all on our backend, it's not a part of the smart contract.
Just to be clear, so basically everyone creates a channel with the guardian. The guardian is this hub in the middle, right?
No. We are not creating the channel with guardian. Let's say there's an Alice and Bob.
Guardian prevents double spend.
Yeah.
Because you just ask it, it's like the Oracle, which is still centralized. So it's a centralized system that's not trustless in terms of that. So like if your guardian goes malicious, it means that somebody can double spend like all the money, and
it just goes down.
Not exactly. You cannot double spend because on the contract side there is a limit on the deposit. So if you withdraw something from the channel, if you commit the channel twice, you always commit with the higher amount in the channel. So you cannot commit the channel, you cannot do the double spending with the different amounts, because you need to have a signature from the sender and the guardian. So if the guardian can sign only once for the total amount in the channel.
Like, I guess before it's withdrawn, you can do something with it, right? Yeah, I'll think about it. What can happen in that case if the guardian goes malicious or something? But yeah.
Guardian can sign something, but still you need to have a signature from the sender, and you can check the balance of the sender. And we don't keep all of the balances inside a single contract, but in the payment deposit addresses. So still, payment deposit have a limit, so you cannot withdraw more that's in the payment deposit, and you cannot withdraw more that is in the channel, and you cannot submit channel twice.
Can you, when you're withdrawing, can you submit old state, like not the latest one?
Yeah. So for example, let's say we have a partial payment. I will send the first 1 ETH, then I will send the 2 ETH, and then I will send a 3 ETH. So the total amount will be 1. if I want to send another one, the total, I want to send 2, the total amount will be 3. And if I want to send another 2, it will be 5. But if I submit 2, I will, let's say I will withdraw 2 from the channel, then I can withdraw only 3. I can withdraw only the difference between what is currently in the channel and what was committed.
In order to withdraw something, what do? You just provide signatures from Guardian and from the your counterparty, right?
Yeah. And there is 3 methods which currently in the SDK support too. So you can withdraw to your account or to your deposit. But there's also in the code on the payment registry, there's a split. So some of the funds can go to your account and some of them to the deposit. So for example, if you want to cover the cost of the transaction, but the rest of the funds should go to your deposit.